In this video, we're going to look at simple circuits. So we're thinking about electricity and the movement of electrical energy around a circuit. It's important to remember the structure of atoms as we start this topic. Atoms contain a centrally positively charged nucleus, and around that, zooming really fast, are very small electrons, and these are negatively charged. And it's the movement of electrons that allows electricity to flow as electrons flow from one area to another. So if we look at a conductor, so that will be something like a metal. There are a couple of non-metals that can conduct, but in general, we will be dealing with metals that conduct electricity. The central nucleus of the atom of metal stays in place in the wire, but the electrons are able to flow from atom to atom as shown in this picture. And it's the flow of electrons that is what we call electricity. Now, you can move electrons from one place to another, and if that place you've moved them to is an insulator, they will not flow. They will stay in place, and we call that electrostatics because there is no flow of electrons. So electricity can only happen when there is a flow of electrons. In order to flow, we need a simple circuit which consists of loops of conductors joined to each other. And then we need something that will push the electrons around the circuit, and that is our power source. So a battery, like in this picture, provides the power source. So it provides a potential difference or voltage to the circuit. And this allows the electrons to flow so long as all the wires connect up in a loop. If you have a break in the circuit, this will stop the flow of electrons. And a break might be a switch, as you can see in this picture, or it might be where one wire is not properly joined to the edge of a component, like a light bulb. So if your circuit is not flowing and you're not getting any globe lighting up or noise from a buzzer, then you might want to check that all of your wires are connected properly and that the switch is closed. Now, to make sure your circuit is safe, we need to have something for the electrical energy to actually do. And the electrical circuits, they provide energy to different components, and those components can then do work as the electrical energy is transformed into other types of energy. So if you have a component which is a light bulb or globe, you will get light energy. And if it is a buzzer, then your electrical energy is turned into sound energy. And if it was something at home like a stovetop or a hairdryer, then your electrical energy would be transformed into heat energy. So if there is no component in the circuit, this would be really dangerous. This is called a short circuit, and it could damage the wires and damage the power source as there's nothing for the electrical energy to be transformed into. When we're showing electrical circuits with their components, we need a common language, and we call this language symbols. And we have agreed symbols all around the world that we can draw an electrical circuit and other people will know what it means. So here are some common symbols that we're going to be using. Sometimes you see old-fashioned symbols, for example, a light globe. Sometimes you see a circle with an X in it instead of the little bump that's being shown in this diagram. And sometimes a resistor is shown as a wiggly line. But in general, these are the agreed upon symbols for your circuit diagram. And when you put them into a circuit, you will notice a few key features. The wires are shown at right angles going around like a box. That's called snap to grid. And that's just a way of keeping your diagram looking neat and easy to interpret. It doesn't actually matter where you put the bulb. You could put it on the sides or on the bottom or on the other side, so long as the loop makes sense and it matches the circuit. So in this diagram, we have a power source, a cell, we have an open switch, and we have a light globe.